We're going to look at 11 problems where we have to solve exponential equations. Here's the first problem. I have 5 to the x is equal to 5 to the negative 6. Let's find x. So to do that, what we want to check is if we have the same base. As long as we have the same base, then we can just set the exponents equal to each other. So in this case, x is equal to negative 6. And that makes sense, right? Because if I put a negative 6 here, I'll have 5 to the negative 6. Here's our second problem. 3 to the negative x is equal to 81. Now this time I don't have 3 raised to a power over here. But that's okay because I can write 81 as 3 raised to some power. Remember that 3 times 3 times 3 times 3, well this is 9 times 9, which is 81. So in other words, 3 to the 4th is equal to 81. We can substitute 3 to the 4th for 81, so we'll have 3 to the negative x is equal to 3 to the 4th. And now we have the same base. So all we have to do is set negative x equal to 4, and you'll see that x is equal to negative 4. And let's plug it in to double check. So 3 to the negative x, well if x is negative 4, we'll get a negative times a negative is a positive, so 3 to the 4th, which is 81. Let's try this problem. 1/4 x, 1/4 to the power x is equal to 1 over 64. We're going to do something very similar here. Notice that I have 64 on the bottom. Is there any way that I can write 64 as 4 to some power? And the answer is yes. 4 times 4 times 4, well that's 16 times 4. And if you do the multiplication, you'll get 64. So in other words, 64 is 4 cubed. So I can write 1 over 4 to the power x as 1 over 4 cubed. Now I have a couple of different ways I can solve this. One thing I can do is I can pull this 3 outside of everything because 1 is equal to 1 times 1 times 1, which is 1 cubed. So instead of putting this 1 here, I could write 1 cubed. So here's one option. And then I can take that 3 out. So from here I can say 1 over 4 to the power x is the same thing as 1 over 4 cubed. Because this 3 will be sent to everything inside, so you'll get 1 cubed and 4 cubed, exactly what we have right here. And in that case, now we have the same base. You can see we have 1/4 raised to a power and 1/4 raised to a power, so we just set these exponents equal to each other, and we get x is equal to 3. Again, you can double check by just plugging 3 into here. So if you plug in 3, you'll get 1/4 3 times. Well, if you multiply 1/4 by itself, and then again, you will get 1 over 64. I do want to mention there's another option, and it's good to practice different ways to do this, just so the more ways that you see something, the more experience you have, and that will help you when you solve other problems. So something we could have done right here is I could actually move this 4 up to the numerator by making this 4 to the negative 1. So taking this 4 and sending it up is the same thing as 4 to the negative 1, because this has a power of 1 here. And this 1 over 4 cubed is the same thing as 4 to the negative 3. When you take something that's in the denominator and send it up, you put a negative in its power. And then this part right here is 4. Well, remember that rule, if we have something raised to a power with parentheses raised to another power, we just multiply these two together. And you see that you'll get negative x is equal to negative 3, so x is 3, just like what we had before. Let's try this problem. 5 to the x plus 3 is equal to 1 over 5. This problem has two options. We can write this 1 over 5 as 5 raised to a power, so we can get the same base, or we can write the 5 as 1 over 5. So it's your choice. I think what I'm going to do is I'm going to write this one as 5 to the negative 1. So we get 5x plus 3 is equal to 5 to the negative 1. And because we have the same base, we get x plus 3 is equal to negative 1. Move that 3 to the other side, and you get x is equal to negative 4, subtracting 3. And again, plug this in, always double check. If you plug in negative 4 plus 3 is negative 1, and you do get 1 over 5. So the other way you could do this, here's the problem again, is you can write 5 as 1 over 5. So this is the same thing as 1 over 5 to the negative 1. That's what I mean. 5 is the same thing as 1 over 5 to the negative 1, because when you have a negative, you can put it up in the numerator by changing this to a positive. This way is a little more complicated. 1 is the same thing as 1 to the negative 1. So from here, you have 1 to the negative 1 over 5 to the negative 1. X plus 3 is equal to 1 over 5. And then you can pull that negative 1 on the outside. So you'll have 1 over 5 to the negative 1 times x plus 3 is equal to 1 over 5. And this 1 over 5 is raised to the power 1. And then you can say that negative x minus 3 is equal to 1, because we have the same base. So negative x minus 3 is 1. And then you just solve for x. So you can move the x to the other side and the 1 to the other side. So you get the same thing. Now again, this way is a little more complicated, and you really have to understand how exponents work to get to this answer. I like this answer better because, or this way of finding the answer better, because it's quicker and it makes a lot of sense. Let's try this problem. We have 4x squared is equal to 2 to the x. Here we do not have the same base, but it is possible to write 4 as 2 squared. So remember that the goal is to get the same base, if it's possible to get the same base. Now I can't really write 2 in terms of 4, but I can always break 4 down. So 4 is the same thing as 2 squared. And because of that, instead of having this 4 here, so I had a 4x squared, I can put 2 squared. And remember your property with exponents, if you have something raised to a power here, then raised to another power, you just multiply these two together. So you get 2 to the 2x squared is equal to 2 to the x. Now we have the same base, so that means 2x squared is equal to x. And what you want to do here is notice that you have a quadratic, so move everything to one side. 2x squared minus x is equal to 0, and then factor. So I can take out an x, and I get 2x minus 1 in parentheses is equal to 0. So we get that x is equal to 0, or x is equal to 1/2. If you set this 2x minus 1 equal to 0, you'll get 1/2. And let's double check. Let's see if that's true. So I'm going to erase this little bit here so I can have some room. So 4 to the 0 squared, is that equal to 2 to the 0? Well, 0 squared is 0, and any number other than 0 itself, but any number raised to the power 0 is going to be 1. And 2 to the 0 is also 1. So that worked. Now let's try the 1/2. So we have 4 to the 1/2 squared. Is that equal to 2 to the 1/2? Well, 4 to the 1/2 squared is 4 to the 1/4. And we're going to leave this side alone. Let me just focus on the left-hand side. We can write 4 to the 1/2 as this 4 is 2 squared to the 1/4. And you see if you multiply these two together, you will get 1/2. So it is true. Let's try this problem. 9 to the negative x plus 15 is equal to 27 to the x. Okay, remember we tried to get the same base as the first step. Now, it's hard to write 9 in terms of 27. Can we write 27 in terms of 9? Now notice that 27 is equal to 3 times 9. So that's not 9 squared and it's not 3 squared, but notice that 9 is also 3 times 3. So what we're trying to do is we're trying to make this 27 as a number to a power. And we can't use the number 9 because, well, 27 is 3 times 9. It's not 9 squared, it's not 9 to the first, it's not multiples of 9. So what we have to do is break it into 3, 3, and 3. But that's okay because 9 also breaks into 3 times 3, right? Because of that, what I'm going to do is I am going to substitute instead of this 9, I'm going to put 3 squared. And instead of this 27, I'm going to put 3 cubed. So this is 3 squared raised to the negative x plus 15. And this is 3 cubed raised to the x. Now from here, we multiply, so we get 2 times negative x plus 15 is equal to 3 to the 3x. And then send in this 2, so we get 3 to the negative 2x plus 30 is equal to 3 to the 3x. Same base, now we just set the powers equal to each other. So we have negative 2x plus 30 is equal to 3x. Add 2x to both sides. We get x is equal to 6. Okay, a good thing to always do is to double check. So if I make some room here, we said x is equal to 6. So let's see, is 9 to the negative 6 plus 15, is that equal to 27 to the 6? I don't know, let's see. 6 plus 15, negative 6 plus 15, that's 9 to the 9. That's the left-hand side. But notice that we have 9 nines. Well, that's the same thing as 9 cubed, because 3 times 3 is 9. And then from there, what can we do? Well, I'm trying to make it look like this, and it looks like I ran aground. I can't do much with that. So maybe we could just put it in a calculator, see if 9 to the 9th power is 27 to the 6th. It is, but we could also say, okay, this is 3 squared to the 9. And from there, I can say, well, this is 9 to the 18. I need 27, right? So 27 is 3 of these. So 6 times 3 is 18, and then I got 27 to the 6. It would be much quicker and much simpler to just plug this in the calculator, see what that is equal to, and then plug this into the calculator and see what that is equal to. These are going to be large numbers. So if you have a scientific calculator, you might have trouble getting this full number in the calculator. So what I'm trying to do is I'm just trying to rewrite it so I can see if I get 27 to the 6th. And I noticed that 9 is the same thing as 3 squared. And so then I could just multiply these two together and I get 3 to the 18th. And then from there, I know 18 is the same thing as 3 times 6. And the reason I did that, broke it into 3 times 6, is because I know 3 cubed is 27. And I was able to get what I wanted. All right, here's our next problem. 5 to the x squared plus 8 is equal to 125 to the 2x. Maybe you should pause the video and see if you can figure out what to do with this problem. Remember, try to get the same base. So maybe pause the video and see if you can get these as the same base. All right, so we have 5 to the x squared plus 8. Notice that 125 is 5 times 25, which is also 5 times 5 times 5, or 5 cubed. So this is the same thing as 5 cubed to the 2x. That means we have 5x squared plus 8 is equal to 5 to the 6x. And now we can set these exponents equal. We get x squared plus 8 is equal to 6x. This is a quadratic, so let's move everything to one side. I'm going to move everything to the left side, and I get x squared minus 6x plus 8 is equal to 0. And now you need to factor this. So we've done a lot of factoring. This is going to factor into, just looking at it, I know that we should have a -4 and a -2. Because remember, you need two numbers that multiply to give you a +8, but at the same time add to give you -6. The only way to add to give you this -6 would be if they're -4 and -2. From there, you get that x is equal to 4 if you set this piece equal to 0 and x is equal to 2. So those are our two numbers. Again, I always like to double check. Maybe it's because I'm a perfectionist, but also it might be because I've made a lot of mistakes in the past. And I like to just make sure that what I'm doing is correct. So I don't have to, if I take a test, I don't get it wrong. Okay, so my two answers were 4 and 2. So let's plug in 4. You plug in 4, you get 5 to the 16 plus 8. That's the left-hand side. Let's simplify that. That's 5 to the, I think that's 24. Is that equal to 125 to the 8th? Because 4 times 2 is 8. So this is what we're trying to figure out. Divide this by 3. Because 3 times 8 is 24. And you can see that 5 cubed is 125. So that is 125 to the 8th. So the left-hand side is equal to the right-hand side. Now you try the other number too and see if you get a correct answer. Okay, I'm going to move on. Here's problem number 8. We have 9 to the 2x times 27x squared is equal to 3 to the -1. The idea for this problem is the same, like how to solve this is the same as what we've been doing before. We want to get the left-hand side a number raised to a power, and on the right-hand side we want a number raised to a power. So both the base of the left-hand and the right-hand sides, we want them to be equal. Now, these numbers we've seen before and we know how to break them. And we have this number 3 here. Let's break all of these numbers down as 3 raised to a power. So like this number 9 is the same thing as 3 squared to the power 2x times. This 27 is 3 cubed to the power x squared. And we already have a 3 here, so let's leave it alone. I'm going to simplify this. This is 2 times 2x, so this is 3 to the 4x times. This is 3 to the 3x squared, and this is still 3 to the -1. Now, how can I combine the left-hand side? Well, remember, if we have the same base and we're multiplying them, we just add the exponents. So this is 3 to the 4x plus 3x squared is equal to 3 to the -1. And now we have the same base, so we get that 4x plus 3x squared is equal to -1. So put everything on one side. So maybe move this one over. And I'm going to reorder this so the leading term, the one with the highest power, is in the front. And then try to factor this. Let's see if I can factor it just by using trial and error. I know I need a 3x and an x. I need maybe a 1 here and a 1 here. Let's see. 3x squared. We get 3x, 4x. Yeah, I think that's right. So this is how this polynomial factors. And if you set both pieces equal to 0, you'll get x is equal to -1/3 and also x is equal to -1. So you got two answers. So plug them in and double check. I think I'll check this one because I think this one will be easier to work with, and then you can check this one on your own. So let's see if -1 works. Okay, so x is equal to -1. So I want to see if 9 to the 2 times -1 times 27 to the -1 squared, is that equal to 3 to the -1? So let's simplify this left-hand side. This is 9 to the negative 2 times 27 to the first power. Well, this is 1 over, 9 squared is 81, times, this is 27. So we got 27 over 81. Okay, is 81 divisible by 27? Pull out a calculator. 81 divided by 27 is 3. So then we have this becomes 1 and this becomes 3, and we get 1 over 3, which is the same thing as 3 to the negative 1. Here we have the number e. Now, this is a number. Remember, it's like about 2.71, somewhere around there, but it's still a number, and I have 3 of them. So we're going to approach this problem in a way that's similar to the last problem. In fact, I think it might be even easier because the base is the same for each one of these. Okay, so let's simplify a little bit. We have e to the 4 to the x. So this is just e to the 4x times ex squared is equal to e to the 12th. And then we're going to do the same thing we did last time, which was to add these two. So we have 4x plus x squared. That's e to this is equal to e to the 12th. And now we have the same base, so we just set the exponents equal to each other. Move everything to one side. How can we do this? I think this is x plus 6. X minus 2 is equal to 0. 6x, that will give me the 4, and then the negative 12, yeah. So the two answers will be negative 6 and x is equal to 2. So double check those, make sure that they work for this problem. Maybe I'll do, because this is a different number, I'll do x is equal to 2. So let me move all this down. So the question is, for x is equal to 2, is e to the 4 to the 2 times e to the 2 squared, is that equal to e to the 12th? Well, this side is e to the 8th times e to the 4th. Add these together, you get e to the 12th. So it was correct. Just 2 more problems. These are more interesting. We have, if 2 to the x is equal to 3, what does 4 to the negative x equal? So maybe pause the video and think of something. See if you can maybe rewrite this 4 to the negative x as 2 to the x raised to some kind of power, and see if you can go from there, what you can do, and then come back. Okay, notice that 4 to the negative x is equal to, well, 4 is 2 squared, so we have 2 squared to the negative x, and that's 2 to the negative 2x. But I could also write this as 2 to the x times negative 2. So just notice that x times negative 2 is negative 2x. So I didn't do anything wrong. I'm just rewriting these things. I'm trading the places of these and moving the negative with this 2. But we know what 2 to the x is. That's 3. So this is 3 to the negative 2, which is 1 over 3 squared, which is 1 over 9. That was kind of fun. Let's try one more like this. Now see if you can do something similar. Maybe pause the video and try this problem. So 5 to the negative x is equal to 3. We want to know 5 to the 3x. So what can we do? Well, 5 to the negative x to the negative 1, that would give me 5 to the x, right? Well, what if I, instead of putting a negative 1 here, I make it a negative 3? So 5 to the negative x to the negative 3, that will be 5 to the 3x, which is what we're going for. So if I know what this side is, that will give me this right-hand side, which is what I want to find. But I know what 5 to the negative x is 3. So we get 3 to the negative 3 is 5 to the 3x. But 3 to the negative 3 is the same thing as 1 over 3 cubed. And 1 over 3 cubed is 1 over 27. So that's our answer. Now, one question you might be wondering from maybe not these two problems that we just did, but from the other problems we've seen, what if we have something like 5 to the x is equal to 3 to the x? Maybe like x squared, something like that, where the bases can't be written in terms of each other. So there's no way that I can write a 5 in terms of 3, and I can't write a 3 in terms of 5. If I scroll back up, I hope you don't mind, I'm just going to show you the other problems that we did. So like this problem here, number 9, it all had e's. But then problem number 8 had a 9, 27, 3. All of these numbers are different, but we were able to write each one of them in terms of this one. But this problem that I'm showing you, way down here, you can't write this one in terms of that one. So we're going to learn about logarithms, and that will help us solve these types of problems. That'll be maybe in the next couple of videos, we'll learn about that. So we'll be able to solve this soon.